Hi, everyone. My name is Conrad. I'm from RTE. We're the national broadcaster in Ireland. And together with Al Jazeera and Associated Press, we're champions in this project. The three champions in this project together probably have over 100 years of involvement in the news industry. We've literally gone from where news contribution used to be rushing tapes to a train station and getting it to a train to get on air, to people expecting their news to be delivered in the highest quality possible as quickly as possible. We, at the moment, drive that through various methods, open networks like the mobile networks, satellite networks. Our reporters generally report from areas, a wide variety of areas. You can think of huge protests where everyone's on their phone filming and the network might be congested, football matches, soccer matches, the literal back end of nowhere in Ireland where 5G hasn't even been heard of. You'd be happy if you got 2G. War-torn areas, areas where the infrastructure may be damaged or non-existent. To do this, we use a variety of tools, generally little backpacks with multiple SIM cards, sometimes up to 6 to 10 SIM cards bonded, or satellite, expensive satellite connections. Unfortunately, they're great, but unfortunately they still have an occasional issue. This is a little dramatized version. It wouldn't actually really ever happen on air, but that's only because we would stop it. What in reality happens is the story doesn't make it to air. So we would actually lose coverage. And this is something that we tried to address in this specific catalyst, to see if we could tackle the problem from the opposite end. Instead of just widening the bandwidth and using more expensive tools, if we could also improve the compression. So with that, I'm going to hand over to Gwenda from Vinova to talk through some of the compression work that Vinova has done on this project.
I have this.
Oh, you have it.
Thank you, Conrad. So earlier you heard about one of Vinova technologies to address, to speed up AI. Now we're going to talk about proper video compression to address the issue of our sponsor. So what we're aiming at is improving quality and reliability of live news transmission, especially within bandwidth-constrained scenarios, because it's true that 5G will come, but it's not going to be up to speed at scale for the next few years and not everywhere. So in the meantime, I mean, video quality is exploding. People have 4K TVs in their rooms, but news gathering very often, as we observe by looking at the right footage for the demos, is still in SD resolution. So to do that, we use Vinova's Persus Plus video codec enhancement. To explain what it is, the simplest way is to think about the hybrid engines, where the electric engine is actually supporting and improving the performance of the traditional engine. So in a similar way, Persus works on top of existing standard codecs to improve the performance, the compression performance, but also reduce the complexity. And Persus can run in combination with legacy codecs such as H.264, but also with next generation, which are now current generation actually, HEVC or BP9, and then future generations such as AV1. And it can enhance compression, but at the same time reduce complexity to the point that it can be implemented as a software update on any existing device, including the backpacks that our sponsors are already using, or simple mobile phones with a simple software update. And Persus Plus is also the basis of a new MPEG 5 Part 2 standards, which has been standardized in the next 6 months. So this will be the first news gathering implementation compliant with the new standard. To give you a couple of numbers, this chart shows a proxy for video quality. In blue is the line for purses. In red is the standard H.264 technologies. As you can see here, depending on the operating point from 1 to 3 megabits, Persis Plus always outperforms in terms of video quality the benchmark. And if you focus on a specific operating point, such as a 1 megabit operating point, which is super relevant for broadcasters because that's the bandwidth that is typically available for in real life, depending on the complexity of the frame, the advantage can be massive. So in highly complex scene, like this or this, H.264 collapses in blocks, while Persis can still hold and preserve robustness of the quality. In easy scenes, they are pretty aligned, but easy scenes are those where, I mean, every codec could do it, and it's not really relevant to improve. So this is an example of what happened in a complex scene at 1 megabit. On the left, legacy H.264, on the right, Persis, which is not perfect, but is totally transmittable, and is still full HD at 1 megabit. So broadcasters like Al Jazeera wouldn't be forced to reduce the resolution to SD or sub-SD in order to fit the network, but you can afford to keep the resolution up, knowing that it's never gonna collapse. This is another example. In this case, it's a slightly higher bandwidth, 1.5. And this is another example where with Persis you can get a much cleaner representation of certain areas. And for instance, you could, with AI algorithm, read the text while you couldn't on that case. This is an example, and this is an initial experiment that we did on some archive footage from Associated Press. On the left, you see an example of H.264, and you can see a lot of very nasty artifacts that would make the video completely unwatchable. Even at increasing bandwidth, is still exploding in a lot of blocks, while, I mean, with Persis, even at low bandwidth, you can still see what's going on. On easy scenes like that, actually, there's not much difference because that's not the issue. If you come and visit us at our booth, we have more demos of this. Considering that we have 2 layers that work together with the base layer and the Persis announcement, we can control much better the jitter. And so the spikes in the case of Persis in highly complex scene are much lower than the spikes that you would get with H.264. And so you can feel the available bandwidth, the pipe, much better. And also there is another dimension, which is that Persis Plus includes 2 layers of quality in one. So you have a lower resolution, lower quality layer, and then when you add the Persis data, you get to a higher quality layer. So imagine a scenario which is a real case scenario with cellular bonding, where you have the total bandwidth that oscillates quite a lot. So in this case, it goes up to 6 megabits, and then it suddenly dropped to around 2. In a traditional use case with backpacks, there is a feedback loop that detects the reduction of the bit rate and reset the encoder in order to record at a lower quality and lower resolution. But this takes a few seconds, so there is an interruption in the video for a few seconds, so it's not a smooth transmission. With Persis, you would have included in a high-quality feed the 2 layers. So if the bandwidth is reduced, you can automatically switch to a lower quality, pretty seamless, without delay. So we believe that the combination of compression, reduction of jitter, and the 2 layers in one can be transformational for the news gathering industry, and can help our sponsors and the rest of the news industry to actually improve the quality of live news transmission. Road to IBC, what we're looking to do at IBC is to transform this concept into a real product and a real solution that broadcasters can use. And so we are already in touch with major vendors in the space, such as AV West, to integrate our compression software into their equipment. We will test both on the backpacks and also on mobile devices. And hopefully we're going to do a live transmission at IBC. Thank you very much.
Thank you very much.
Come and see us at our booth in the Catalyst area downstairs if you have more questions.